While you might usually use this term to describe Hugh Jackman, Channing Tatum, or even yours truly, this was the term used by Josh Schoenwald, author of The Taste of Tomorrow, to describe the world's first lab-grown hamburger. Himself and fellow taster Honey Reutzler both volunteered to taste what has been dubbed the $330,000 hamburger, developed by Mark Post of Maastricht University and co-funded by Google co-founder Sergey Brin. The team had been developing the burger by growing individual strands of cow cells since 2008. However, on August 5th of 2013, the team had finally collected enough individual strands of cells in order to form one piece of meat. But why go through all the trouble and money? Bloomberg News, reporting from the West London tasting site where the burger was being tasted at, says that Post and his team are concerned with traditional methods of livestock, which, according to one Oxford University report published in 2011, explains that conventional livestock takes up 70% of all agricultural land. That's 30% of all ice-free land on the planet, and also contributes to 18% of global greenhouse gas emissions. Post and his team go on to explain that they're catering to people who want to eat beef, but do it in a sustainable way. However, the process of in vitro or cultured meat technology doesn't just apply to beef and could be used to create any type of meat from any animal. Because of the potential of this technology, today we will be examining in vitro meat by first understanding what in vitro meat is, as well as what differentiates it from normal meat. We'll then look at the process of how in vitro meat is grown, before finally examining the benefits and drawbacks of this astounding leap in food technology. First, cultured meat is normal meat. According to Sandra Stringer, senior microbiologist at the Food Research Institute in Norwich, England, on August 5th of 2013. She explains that much of the misconception stems from the fact that when people first hear about cultured meat, they automatically assume that it's some sort of GMO, or genetically modified organism. However, she says that that comparison is unwarranted, because at the cellular level, there's nothing to distinguish normal meat from cultured meat. Now, you're all probably wondering, if it's all exactly the same at the cellular level, does it really still taste the same? Well, not quite. Peter Verstraete, a Dutch food scientist who worked with Mark Post and his team on August 4th of 2013, explains that a normal beef burger gets its juiciness from fat cells, and its red color from remnants of skeletal cells, blood vessels, and blood, whereas a cultured meat burger currently gets its from beet juice and saffron. Yum. He goes on to explain that the process of cultured meat means that only muscle satellite cells were used in the creation and formulation of the beef burger patty, not giving enough cell diversity to create the complex tastes that are found in a normal piece of meat. However, Post and his team acknowledge that while taste is a complex issue, it's one that they think that they can overcome, as they're already working on ways to create in vitro fat cells to add into the next iteration of the cultured meat burger, which could help eliminate some of what the Washington Post calls the yuck factor, as in vitro meat has already been called frankenmeat and schmeat by many people in the public. So now that we understand what cultured meat is, let's look at the process of how it's grown. Although the team had been developing the burger patty since 2008, it actually only took about 3 months to grow all of the specific cells that were used in the tasting that took place in West London. That's because much of the process takes place at the research and development level beforehand. Reuters on August 2nd goes on to explain this process in more detail. They first explained that the scientists had to extract a stem cell culture from a fetal bovine serum. And as you may already know, these stem cells could be turned into potentially any type of cell within the animal. They then ran extensive testing, figuring out which cell variety would actually be the most effective for their meat patty. The scientists eventually settled on the muscle satellite cell, which is found in the cow shoulder and can aid in muscle regeneration. However, the article goes on to explain that although muscle satellite cells were most effective for a cow, different animals and different cuts of meat might have different cell types that would actually be more effective. And this process would need to be repeated for whichever type of meat was trying to be got. Now, after they finally settle on a type of cell to use, the process is fairly straightforward. It simply involves extracting the stem cell culture and then replicating and growing it over and over again until they finally have enough to form one piece of meat. For the 5-ounce burger patty that was tasted in West London, that was over 20,000 individual strands of cells. And while that may seem like a lot, keep in mind that Tech News World on August 4th of 2013 explains that just one stem cell culture could produce over 20 tons of meat. Because of the astounding potential to produce large amounts of meats, we must look at the benefits and the drawbacks of this technology. Let's start with the benefits both to our planet as well as our own personal health. First, there are numerous benefits to our planet. According to the Food and Agricultural Organization, or FAO, which is underneath the United Nations in a 2006 report, they note that conventional livestock contributes on a massive scale to climate change, land degradation, air pollution, and declines in biodiversity. Additionally, the report explains that they are expecting a 50% increase in demand for meat as developing countries like China and India begin to increase their meat consumption in coming decades. Beyond just meeting the demand for meat, however, are also significant benefits to the cleanliness of the process. Hana Tiamotsu, an Oxford University researcher in a 2011 report, explains that by switching over to in vitro meat production, we could save 30 to 65% on energy costs, reduce our air pollution by 80 to 95%, and cut down on our land usage by 98%. In addition to the benefits to our planet are also benefits to our personal health. Joan Blake, a Boston University researcher, explains in his book Nutrition and You that the process of in vitro meat often takes place in a sterile lab environment, which is much less prone to risks of disease and cross-contamination than in traditional meat production. Additionally, if at the cellular level, scientists were able to replace trans fats with omega-3 fatty acids, that would be potentially beneficial to our health, especially considering the new FDA regulations, which are controlling how much trans fats are actually allowed in most foods. However, despite the optimism of the scientists and those involved in this project, there are still numerous obstacles that need to be overcome if we can ever expect in vitro meat to become a supermarket staple. John Tillotson, a Tufts University researcher and international business professor, states on August 6th of 2013 that there is going to be extensive testing on in vitro meat, not just for controlling the spread of microorganisms in a lab setting, but also in production and distribution as well. Beyond this testing is more testing on the effects of eating synthetic meat on the human body, and that's a lot of testing. In fact, he goes on to explain that we won't actually see in vitro meat in the supermarket for about another 10 years. Beyond these issues in time frame are also issues in price. Post and his team think that 1 pound of cultured meat is going to cost about $35. That's filet mignon price for not quite beef taste. However, Post and his team feel like these problems and numerous others can be overcome, as they state that a lot of the problems stem from a lack of funding, as in vitro meat has been considered a fool's dream ever since the 1970s, when NASA attempted to do this process by creating goldfish nuggets for astronauts, and more recently when a pair of Australian bioartists attempted to popularize the method in 2003. However, with Post's West London proof of concept being a success, he believes that funding for his project is only going to increase in the coming years, which could reduce both the price and the time it takes to get this technology to the market. So today, we have examined in vitro meat technology. And by understanding what it is, as well as what differentiates it from normal meat, looking into the process of how it's grown, we can understand Mark Post and his team's optimism as they attempt to combat some of the most serious issues facing our meat consumption in the future. The tasting in West London was a success. Neither taster spat out the burger, cringed, or turned green. And with the serious issues and problems facing our meat consumption, let's hope that Josh Schoenwald and Hani Reutzler aren't the only two people to taste a lab-grown meat burger.